Up next is 1.3 complex numbers. So to complete our discussion on techniques for solving equations in one variable, we need to expand our set of numbers. Sorry, I had to take a sip of water there. Throughout history, numbers developed as they were needed to answer questions and solve problems. So first up, I'm going to explain the problem. A number c is the square root of a real number b, provided that c times c equals b. Right, so how many square roots does the number 25 have? Well, we know that 5 times 5 is equal to 25, but also negative 5 times negative 5 is also equal to 25. So it actually has 2 square roots. How about the number 7? Well, the number 7, while not as nice as 5, it also has 2 square roots. Because we've got root 7 times root 7, which is really root 7 squared, is equal to 7. So just like 5, if we've got the positives, we also have its negative counterparts. Right? No one said these things had to be pretty. We just said it needed a square root. So it's got 2 square roots as well, positive root 7 and negative root 7. How about 0? Well, 0 has that 0 times 0 equals 0. 0 doesn't have a negative or positive connotation with it, right? It has no value. So it just has 1 square root. But now, if we ask the same question of negative 4, this is where we run into trouble. Because if I've got negative 2 times 2, that equals negative 4. But negative 2 doesn't equal 2, so it doesn't fit our value, or our definition, right? A square root says that the same number times itself gives us b, right? So here, negative 4 doesn't have any square roots, but we need to have a root for negative 4. So this is why imaginary numbers were created. So in order to fix this situation, what did we do? Well, we invented a number, right? A number was invented. It's called I, right? So a number I, it's called the imaginary number. Who would have thought imaginary starts with an I? So we used I. Remember in math, they called it like they saw it. Tired from inventing the math, so they didn't get too creative when labeling this stuff. Luckily for us, right? The math is hard enough. I don't need to think about a crazy random title. So I is equal to the square root of negative 1. So this means that I squared is equal to negative 1, right? Because the square root of negative 1 times the square root of negative 1 is equal to negative 1 squared, which in turns is negative 1. Do y'all see that? Oh yeah, I'm on the page. Perfect. All right. So now we're going to ask again, how about square roots of negative 4? Well, now I can have the square root of negative 1 times 2 times the square root of negative 1 times 2. And this is equal, 2 times 2 is 4, right? I can reorganize this as the square root of negative 1 times the square root, of negative 1 times 2, which we see is, let's make that a 1. This here, right? This is negative 1. 2 times 2 is 4, so that's how we get negative 4. But remember, the square root of negative 1 is I. So this is I times 2 times I times 2, right? Which is I squared times 4. And that gives us negative 4. So 2i is a square root of negative 4. But just like 5 and 7 above, we don't just have its positive friend, but we also have its negative version as well. So the square root, or actually negative 4 has two, whoops, imaginary square roots. Cool, huh?